Volcanoes. Hawaiians have observed volcanic processes since ancient times. Observations. Traditional. Human observation is an effective monitoring tool. Hawaiians use this tool much as scientists do today, with one important exception. Today, scientists observe and monitor volcanoes using a variety of instruments that detect changes. Traditional observation. Traditional Hawaiian scientists observed the changing forms of volcanoes. In ancient times, observations were committed to memory and passed from generation to generation in the form of lono, oli, mele, hula, mo'olelo. Lono. Lono are reports which in ancient times were oral. Detailed observations of volcanic activity, such as the boundaries of a flow and a prediction of where it might go, were brought to the chief of the island. If the flow threatened a breadfruit grove, for example, the chief might dispatch messengers with the report, along with a couple forbidding visits to the grove. Traditional observation. Oli. In times when television, radio, and newspapers did not exist, people composed oli to help them remember and share information with family who did not hear the original report of volcanic activity. Traditional observation. Mele. In ancient times, people composed mele to help them remember details of specific volcanic activity, such as a lava flow. The mele might imitate the sounds of the flow in addition to providing descriptions. Traditional observation. Hula. Hula was composed to depict the drama and suspense of a story. During the hula, dancers could use their bodies to imitate the nature of a particular lava flow, taking viewers back in time as if they actually witnessed the event. Traditional observation. Mo'olelo. Mo'olelo often were used as historical accounts of volcanic activity. Mo'olelo could be told in simple storytelling style or as a more epic drama. Traditional observation. Today, scientists at Hawaiian Volcanoes Observatory use mo'olelo and other historic accounts as guideposts for studying old eruption flows and activity patterns.
glimpses of the past. Hawaii's dramatic volcanoes can be both creative and destructive. Since ancient times, leaders have taken action to protect people from dangerous eruptions and other volcanic activity.
King Kamehameha I. In 1801, Kamehameha I was told of a lava flow threatening his fish pond in Kona. He was advised to make a sacrifice to stop the flow. He threw several offerings into the lava, but the flow ceased only when he offered a lock of his own hair. 80 years later, another lava flow threatened the town of Hilo. The people asked for a relative of Kamehameha to come and convince the flow to spare their homes and towns. A great-granddaughter of Kamehameha, Princess Ruth Ke'elikolani, traveled to Hilo to represent her family. Kamehameha I. Personal information. Kamehameha I was born at Kohala on the island of Hawaii between 1740 and 1758. Through warfare, he defeated chiefs on the island of Hawaii, Oahu, and Maui. Through peaceful surrender, he acquired the island of Kauai. By 1810, all the islands were under the rule of Kamehameha. As the first sovereign of the Hawaiian kingdom, Kamehameha enacted a new form of government, established formal relationships with foreign merchants, and regulated trade. When Kamehameha died on May 8, 1819, his remains were entrusted to a warrior chief who hid them well, never revealing the king's resting place. King Kamehameha. Princess Ruth. Personal information. Princess Ruth Ke'elikolani Kanahoahoa was born in 1826. She was a great-granddaughter of Kamehameha I and attended the chief's children's school with the rest of the royal children. Her first husband was Leleohoku, the governor of the island of Hawaii. Upon his passing, Princess Ruth inherited his seat of power. She later married Isaac Young Davis, a foreigner. Princess Ruth was well known as a staunch practitioner of Hawaiian culture. She spoke only Hawaiian and disliked traveling abroad. Princess Ruth died in 1883.
The magma chamber expands and contracts as the liquid and gas inside changes. Measuring the width of the caldera on top of a volcano is one method scientists use to determine changes of the magma chamber. As additional magma enters the chamber, it inflates until pressure becomes so great an eruption occurs. As lava flows to the surface, the magma chamber deflates and the cycle can begin again. Measuring slope. The slope of a volcano changes as the magma chamber inflates and deflates. The inflation of the magma chamber causes an increase in slope on the sides of the volcano. The deflation causes a decrease. Recording earthquakes. As the magma chamber inflates, it cracks the earth around it, creating vibrations called earthquakes. These vibrations are recorded by seismometers. Magma chamber inflates, cracking the earth. Vibrations move through the earth. Seismometer records the vibrations. Vibrations recorded on a seismogram. Monitoring gas. As magma rises into the magma chamber, gas bubbles out. As the magma chamber inflates, gas escapes through cracks to the surface. The main gases released by volcanoes are water, sulfur dioxide, and carbon dioxide.
Measuring SO2. The amount of SO2 released by a volcano is measured remotely by a correlation spectrometer, COSPEC, an instrument originally designed to monitor air pollution. Sampling SO2. The COSPEC is mounted in a car and driven underneath a gas plume. The instrument measures the amount of ultraviolet sunlight absorbed by SO2 in the plume and compares it to clear sky.
Tracking lava. Once an eruption starts, its progress can be monitored in several ways. Some of the most common ways include determining lava supply, mapping the lava flow, and monitoring the temperature of lava at the vent where lava erupts. Lava supply. The progress of an eruption can be monitored by measuring the amount of lava coming out on the surface. After lava emerges, it cools and hardens on the outside, creating a network of tubes through which molten lava can flow. Lava is supplied to the front of the flow through this network of tubes. Calculate lava supply. Scientists can measure the lava supply through skylights in lava tubes. The amount or supply of lava flowing through a tube can be calculated using this equation. Supply equals depth times width times velocity.
Calculate the amount of lava flowing through the tube.
Tracking lava. Lava flow mapping. The progress of an eruption can be monitored by mapping lava flows. Each flow boundary can be mapped with a handheld GPS receiver. This information is compiled by computer geographic information system software into a digital map. These maps can help forecast the path of the lava flow. Tracking lava. Monitoring temperature. Monitoring the temperature of lava helps scientists predict upcoming changes. Scientists monitor temperature by taking a sample of lava out of a lava tube. This sample is rapidly cooled in water, which changes the liquid into volcanic glass. By analyzing this glass in a lab, scientists can determine how hot the lava was at the time the sample was taken.